All right, so I thought it was a 5-minute run out for lunch, and I got stuck behind somebody that wasn't moving. So I am here. Our next speaker is Noah Gibbs. He is going to be talking to us about next year app, Ruby Web App Architecture. Noah, when I switch it over, it looks like it kicks you off audio and video, so if you want to turn those back on. Noah wrote Rebuilding Rails, a book on building your own Ruby MVC framework. He taught Ruby on Rails at Carnegie Mellon, and you can clone his Ruby deployment software called Mad Science from GitHub. He's an architect and Rubyist at, I don't even know how to say that, Daqri?
Daqri.
Daqri, D-A-Q-R-I,
yeah,
an augmented reality company. So far, so good?
So far, so good.
He believes that somehow, someday, there will be a second game as amazing as Adventure Construction Set for the Apple IIe. So, Noah, go ahead, take it away.
All right. Thank you very much. Can you folks hear me?
I can hear. That's all that matters.
All right. Wonderful. And can you see my screen share? All right. Well, I'm sharing a screen. Folks, let me know if you can.
I don't see your screen share.
You don't see my screen share. Let me fix that. Maybe it kicked that off too when it went over to me. All right.
Could be.
Screen share. Launch application. Next. All right. It says I'm sharing my screen. Good. So that looks all right. All right, Ruby Web App Architecture. So we'll be talking about all of the various things that happen to a request through your stack and all the programs that make that happen, and a little bit about how you can choose which programs you want to do what and how you configure them. So some things that will happen. We'll see diagrams in a minute, but we'll talk about load balancers. We'll talk about reverse proxies, which load balancers basically are. We'll talk about various app servers. We'll talk about rack, which is a level in Ruby to do the mapping. We'll talk about different web frameworks a little bit and where they live in this stack. And of course, we'll talk about your application, because it's certainly not the same without your application in the mix. So let's follow a request from the outside in. It comes into your cluster if you've got multiple machines there, and then goes to one specific host to be served. Here's roughly what that looks like. So you can have various load balancers and caches on the outside, things that may handle the request before it ever goes to a different server. But most of the time what will happen is the request will be sent to one of your app servers, and your app server will handle it. So some common things that load balancers do for you, this outside layer. They're going to send the request to a lightly loaded server if they can. In general, the whole point of load balancing is your servers each handle about the same number of requests, or if some of your servers are slower, don't give extra requests to them. Try to put the request where it will be served the most easily with the resources you've got. You want to keep track of server load if you can, for exactly that reason. That's how you tell who's lightly loaded, and see if servers are down, because of course you've got hardware failures, you've got potential other problems. And so almost any load balancer will take an app out of take an app server out of the pool if it's having problems and if it's not responding well anymore. And then you get to the host level. We'll see a diagram of that in a second. But on the host, you've got a reverse proxy. That's something like NGinX or Apache. It serves static files, maybe cached requests, and it sends other requests through to your actual Ruby app. And eventually it gets down to your specific Ruby process. So here's what that looks like. There are a lot of pieces on this. But the reverse proxy, again, that's NGinX or Apache for almost everybody. Your app server has a master process and then worker processes. So in the same way that a load balancer balances between multiple machines, an app server balances between multiple processes, or for some app servers, multiple threads. And then on your host, of course, you've got other things like you may be using Redis or Memcache, you may be using a SQL or a NoSQL database for storage, or both. You may have other servers that are doing other stuff on the host. So that's the basics of what it looks like. Your reverse proxy is mostly very fast at serving static files and okay at load balancing between your processes. Usually you want to do something to keep your processes lightly loaded, but this is essentially a load balancer just between, you can either load balance, well, your app server is more of the load balancer, but your reverse proxy can do load balancing as well. It can allow you to have multiple apps and it can map between them. It can do some caching. And again, the big thing that it does is it handles certain requests very fast. It also handles a certain number of weird error cases that your app probably doesn't handle well, like, say, uploading a large file slowly. You can get either Apache or NGinX to accept that and do all of the caching before it ever talks to your Rails process. And that way you're not tying up one of your Rails processes for a long time when it can't do anything because the file's not uploaded. There are some various error cases like that that it'll handle. Sometimes you also see HTTPS handled at this level, and so your app doesn't have to know anything about certificates or secure stuff. You can do that at almost any of these levels, but this is a common place to do it. And you got your app server. So when I say your app server, we're talking about Thin, Unicorn, Passenger, Puma is pretty common. For the historians among you, you probably remember Mongrel. I don't know if anybody but me remembers Racer. Passenger is another pretty good one. Yeah, so you've got a bunch of different app servers. Normally, you will never write direct HTTP code in Ruby. You're not going to be parsing the requests yourself. You're not going to be even parsing things like the query parameters yourself. The app server does a lot of these things. So it's like CGI, for those of you that remember CGI, not necessarily from Ruby. The Common Gateway Interface was how your web server would call other programs to handle requests back in the day. And it has some descendants like Fast CGI that are still pretty commonly used. So your app server handles things like that. It makes the rack interface available to your app server, but it in turn speaks CGI or something kind of like CGI to accept the requests from the web server itself and from the reverse proxy. Your Ruby app server has a master process, and it has a number of workers. The workers are either processes or threads, depending on which app server you chose and how you configured it. But in general, you've got the master, and then you've got the workers. I refer to it as a master process. If you're using threads, it's often all one process. But the master is essentially doing load balancing, usually simple load balancing between the workers. It can also do things like restart your workers. So a good app server should be able to do zero downtime deploys, where you change the code and it keeps running, and it switches out the workers underneath you without dropping connections. So if you upgrade in the middle and somebody's in the middle of a request, they will get their request served by an old worker, and then the next requests to come in will get served by a new worker. So you can drop your new code in without causing any downtime, without cutting anybody off in the middle of a request, and without having any time when you can't serve a request. So your app server also handles that. And then we get down to your process. So the worker receives a request. There's some rack stuff like parsing query parameters. Almost all of you are going to be going through a web framework of some kind, through Rails, through Sinatra, through, I don't know, Camping, Remaze, Cuba, Cramp, Grape, Rocket Pants. There are a lot of them. But almost all of you are going to be going through some Ruby web framework instead of directly through Rack. And so from your point of view, the app server stuff and the rack server stuff all looks the same. You don't need to peek under the covers usually. And then all the way to your application code. You probably know what that looks like, and you've chosen generally to have either multiple processes running your app or multiple threads running your app. That's what you usually have to care about with the app server from your point of view. So here's that worker process. I show rack, I show a bunch of middleware, I show a web framework, and I show your app. These are all things that are loaded into your Ruby process. So this worker process is in Ruby and is the same one that you're used to seeing things happening. Rack, we've already talked a little bit about it. It's Ruby's CGI-like interface. You don't usually need to worry about not using rack. Every Ruby app server supports rack. Every Ruby framework supports rack. In general, you can just pretend rack is CGI as long as you're working only in Ruby. And even outside that level, you can usually wrap it in rack without a problem. But this little code block that you see down here is an example of a very simple rack app. For those of you that do know CGI, you know this doesn't look almost at all like CGI. I consider that a really good thing. But so this run proc.new, etc. The proc.new is the object that you are declaring as your app here. If you directly use rack, this is one way that you can expose that rack interface. Your framework is doing something like this for you, or you can directly use it. There's no reason you can't write your apps in rack. For the same reason, there's no reason you can't write your apps directly in CGI. In fact, the app server is an app, usually in Ruby, that was written to match the CGI interface. You can write your own app server in the same way you can write your own framework. There's nothing magic about the code here. But if you write your own framework, or you otherwise go straight to rack, this is what the rack interface for a one little rack app looks like. And then this is what rack middleware looks like. In current rack frameworks, usually you build your app in a series of layers. So for instance, at that rack middleware 1 layer, you could have rack content type, for instance, as that middleware layer. That is the name of a middleware that you could use there. And what it does is it watches for when your app returns a request. And if you haven't already set a content type header, it looks at your extension and it guesses a content type. You're serving a .html file. Let's put an HTML content type on it, so that the browser actually knows what to do with it and can show it as HTML instead of showing an HTML text file the way you've sometimes seen it do. You can have middleware like rack lock, which means even if you've got multiple threads in your app, multiple threads in your process, don't let more than one request into your app at the same time. And if your app isn't thread safe, that's actually a really good idea. Rack does that automatically in a lot of cases, and Rails does that automatically in a lot of cases. And from your point of view, this middleware, which just delays requests so that only one at a time goes in, is completely automatic. You probably don't even know it's there, though very often it is there. So middleware, it can see and modify requests on the way in, it can see and modify requests on the way out. This is very much part of your whole stack of everything that goes on around your app. And in fact, in Rails, which has embraced rack with a vengeance, you can say, hey, run rake middleware and show me the whole list of middleware that you're already putting in place for me before I add any at all. You can add your own middleware. There's a lot of great rack middleware out there that you can get as gem and just drop right into your app. But Rails has already sort of taken the monolithic Rails stack apart back when they moved to Rails 3. And it's now a giant layer of different middlewares. And you can ask it for what those are. That's not only useful so you know what it's doing and can look up the code, it's also useful because you're allowed to drop your own middleware into the middle of that. And of course, if middleware can modify requests on the way in and modify responses on the way out, sometimes you really want to be at a specific place. Like if there's middleware that automatically gzips your response on the way out, you'd kind of like to be dropped in before it does that so that you don't have to deal with gzipped data. And so, yeah, you're allowed to put your own middleware anywhere in the stack. Rails takes it even farther. You're allowed to use your own middleware inside controllers and things like that as well. So Rails adds several more rack middleware stacks. All right, and so your web framework, which can be inside this middleware layer, it can be outside the middleware layer, it can drop itself in. Rails, again, sort of consumes the entire middleware layer. It makes that on Rails kind of indistinguishable by making Rails into a series of middlewares. But in and out and around this middleware layer, you can have the framework, whether that's Sinatra, which also lets you insert your own middleware, Grave, or Cram. Yeah, any of these various frameworks. Or you can do plain rack, and then you've got no framework at all. You're essentially being your own framework. And you've got other servers there. We talked a little about Redis, Memcache, or another server. These aren't directly involved except through your app normally, although sometimes a rack middleware can do it. For instance, you could have a caching rack middleware that stores things in Redis, and when it sees a request that it recognizes, just serve it out of Redis instead of going to your app, things like that. But in general, these are separate, and in general, your app does the coordinating for them. All right, and finally, the request goes through all of those various layers. It winds up in your app. It's gone through your framework. It's in the API. You know, this is what you think of as the whole picture. When you're serving this request, it has finally gotten to you. And when you think of the whole life cycle of the request from your point of view, this is where it starts. There are just a lot of layers that live entirely out of your site most of the time. All right, and one thing I'm going to mention for completeness is that job queues are another runs on the same machine sort of thing. Very often, if you've got a time-consuming thing that you want your app to do, instead of handling it in an HTTP request, it makes sense to farm it out to an additional server. So this is things like rescue, delayed job, sidekick. There are Beanstalk. There are a lot of various job queues, and certainly you can use those. So that's another thing that can be going on the same host, but it's not usually happening in the HTTP request. Instead, you schedule them from HTTP requests, and you read their output from HTTP requests. So for long-running jobs, that's generally how you do it. Oh. There we are. So let's talk about how you pick these pieces. It's awesome to have all of these pieces and to know what they do. It's awesome to know why you would care about what they would do. So let's talk about how you actually control it. Your app server is generally from your Gemfile. You can also run it from the command line. So when you run Rails server, it will normally pick whichever app server you told it in the Gemfile. Unicorn's a bit of a special case. You usually have to run that by typing unicorn or unicorn Rails on the command line. For some reason, its Rails integration is not actually all that good. But Thin, for instance, another common one, or Puma, you just put it in your Gemfile, you run Rails server, it runs. And even if you have to run it from the command line, you still put it in your Gemfile. You still make sure that your Rails app has access to it. So for your app server, which determines whether you're doing processes or threads and how you configure a number of workers, things like that, your Gemfile and maybe a config file are the way to do it. App servers at this point are all really similar for speed, so I wouldn't spend a lot of your time looking at all the benchmarks between them. I mean, they're fun, but there's a reason the benchmarks are inconclusive. It's because the app servers are mostly very similar, and the big difference is whether you're using processes or threads. Or pick one for simplicity, or pick one because you need a specific feature. For instance, you might pick Thin because you want to run Event Machine. Thin is a great choice for Event Machine. Or you might want to pick Passenger because you like how simple its automatic code reloading is with zero downtime. That's a great reason to use Passenger. You might pick Puma because you want a combination of threads with processes. Most of you don't, but if you did, Puma's a good choice for that. Whereas Unicorn doesn't really do that, and Thin doesn't do that, and Passenger makes you pay money for that. But in general, you should probably find one app server that you like okay and default to it, because mostly there's not a huge amount of difference between them. All right. So what else? We talked about a lot of stuff down near your process. We talked about the web framework. We talked about the app server. We talked about rack middleware. That's all sort of down deep where developers control it. Further out, you have things like your reverse proxy, so NGinX, or your load balancer, so HAProxy. You might have additional layers of caching like Varnish, for instance, which is a reverse proxy and cache, which can be used with these other layers or it can be used instead of some of them. All of those things tend to be deployed by ops people in most companies. And if you're a developer, you usually deploy them when you're provisioning the server. It's a good time to do it. Why is that considered ops, whereas a lot of these other things that are very, very similar are considered developer stuff? I don't know, historical reasons. The reason that the other stuff is ops is because that used to be what ops does. And the reason that more of it is now on the developer side is that we've needed more control over these things. Like as a developer, you care a lot about whether you're using threads or processes. And so in Ruby, we often bring a lot more of the DevOps work right near us so we can control it. And so it's kind of a weird fight, but mostly historical accident for who controls which. And if you're doing it yourself, there's no reason you have to care about who controls which. You control everything. But yeah, these other programs are not chosen from your app or from your Gemfile or anything like that. They're just separate programs that happen to run on the same computer and have their configuration files. There's always more. I'll briefly mention process monitors, which restart your process when it goes down, and they look for trouble conditions. I mentioned here God, Monet, Runit, daemon tools. There are many more. I haven't found a huge amount of difference in quality between them, by which I mean none of them are really seriously good, but there are several that are very competent. Every one I mentioned here is perfectly tolerable, is okay. You'll have occasional frustration dealing with it, but not worse than that. Generally, these are all very solid choices. There are some very bad process monitors out there, so I would recommend picking from this list or doing some research to make sure you pick a good one. Yeah, and we talked a little about operations and how the operations guys tend to be in charge of those other programs, which is fine. again, historical incident. All right. So I've mentioned a lot about rack middleware a while back. If you want to know a lot more about that and how to insert rack middleware and how it works, my book is a really good place to start. One of the things that I wish there were better documentation on in Rubyland is rack middleware. It's so powerful and so interesting and so easy to use once you get the hang of it. Like rack is easy to write. It's easy to drop in other people's stuff. Everything uses config.ru now, so everything allows you to drop in rack middleware, even if the framework doesn't have Rails style support for it. So you can research that on your own. I obviously like my book, but most people like their own stuff. You can find good documentation out there as well. There are many, many blog posts on it. And I mentioned use code RemoteConf for $10 off my book if you want to buy it. I'd appreciate it, but utterly up to you. You can also just trade me your email address for the first couple of chapters, and you probably want to do that before you buy anyway. And if you're curious about the other layers, if you're curious about the reverse proxies and about how all of this hooks up outside your Rails app, I have a free piece of software called Mad Science, which is a full Chef and Capistrano and Librarian, etc. deploy of all of these things to a server. And so that shows you all the little moving pieces assembling a single server that runs your Rails app. It does not currently show you the load balancer, but man, there are so many pieces here that unless you already know the other pieces, wait and learn the load balancer after that. Unless there's a specific reason you need to configure it. All right. So let's see, how are we doing on time? I usually talk fast. I expect we're doing just fine on time.
Yeah, like half hour left.
Wonderful, wonderful. So I can talk about these things for as long as I want. I mean, for as long as you let me, basically. I would prefer to talk about the pieces the audience cares about. So you guys have seen a lot of things talked about at high speed. Is there anything that you would like to know more about? I know people can chat. And thank you, Phil, for the link to the Mad Science software. I appreciate it. Sure. Rails versus Sinatra from a framework design standpoint, Charles writes. That's a great question. So Sinatra has a very simple API. Sinatra was sort of among the first of not the first of the micro frameworks, but one of the first frameworks to have a really crazy simple API. Unfortunately, by being first, it has kind of an ugly implementation, even though the API is very pretty. And so patching into Sinatra is very hard. I wrote a piece of software which was a framework built on top of Sinatra called Olaf at my last company. And so I got a lot of up-close look at how Sinatra runs under the covers. The API is very pretty. The implementation is surprisingly ugly. If you want to build something on top of it, I would highly recommend going to the rack interface instead of Sinatra. The rack interface used to be very hard to use and very obscure, but it's slowly sort of built up in the direction of the frameworks until it's fairly usable by itself. Building something that looks mostly like Sinatra on top of it is a surprisingly small number of lines of code. If you just want Get, so I've got a cute little presentation where I built it in 14 lines. So yeah, that's not to say there's not more than that in Sinatra, but a lot of the things beyond that in Sinatra are not amazing. There are other frameworks called Cuba is the one I immediately remember that are supposed to be easier to build into. And I haven't used Cuba, so I can't tell you, but I'll say Sinatra is genuinely hard to build on top of. The big thing I like about Rails, I know it's huge, is that they do a pretty good job of letting you take apart the layers, and they do a pretty good job of letting you insert things into the layers. The most obvious example of this is it's got the different components, active support, active record, and action model, and action hack, and it's got the pieces you can use individually, but they do a good job even within those modules of making it easy to take apart. I feel like Rails is big and contains more pieces than you'll need, but it's not obnoxious about it. It doesn't make you use the pieces in most cases. Sinatra is small and doesn't have more pieces than you need. In fact, you'll find it doesn't have enough, but it makes it very hard to get under the covers and to take those pieces apart. So I generally use Rails for my stuff rather than Sinatra, even sometimes for APIs, just because Sinatra gets irritating much more quickly. At some point, I should try Cuba or a similar framework just to find out if somebody's done it better, because a micro framework that was easy to use that way would be wonderful. So I see 2 more questions have arrived. Anthony says, as a developer, how do we control the layers above the app server? I'm thinking Docker is a great way to orchestrate multiple processes and treat it as one deployable app. So you can do that. It is possible to build a Docker container that has NGinX and has the app server and has sort of all the pieces up through there. You will be doing a lot of what is usually considered ops work if you do that. That may not be a problem, it may be fine. It may also take a lot of your time. I'll say that many of the ops layers are still very annoying to use. Anything where you're installing, say, Ubuntu packages, it is remarkably hard to rebuild in a lot of cases. Docker sort of paves over that by letting you build it into a binary and then letting you ship that giant sort of mini VM around. And the problem with that is that if something goes wrong in the earlier layers, you may not be able to rebuild it. It's a good option because Ubuntu makes it very hard to get a consistently buildable stack of components. They keep changing things and they keep updating things, and you can't get at the old versions. There's no equivalent of gemfile.lock for your Ubuntu packages. So Docker sort of paves over that, but it's mixed. And the other thing about Docker is that there aren't as good tools for using it on multiple containers put together. So at the layer where you're looking at a load balancer and a cluster of machines, Docker will eventually grow into that use case, but the tools are still very immature. With Docker, you also have to still be very careful, even with many processes running in a single container, because it's so easy to make mistakes like not properly reading processes. Most things that are not designed to run as an init process don't actually run very well as an init process. And there are some things, there are absolutely some projects, including Docker containers, including specific pieces of software that are meant to fix that. They're very new and they're not terribly mature, and so there are still a lot of rough edges. And when you're talking about deploying what is essentially a whole machine within a machine, rough edges often translate into process leaks, memory leaks, other things that can bring your entire system down. You're still doing ops work. Ops work is still complicated and fiddly and potentially difficult. You're just doing it all for yourself without a career full of experience doing it. And so Docker allows you to take a lot more of that responsibility on yourself. But in the same way that bad ops work will destroy your entire site, bad ops work done by developers will still destroy your entire site. So you have to get competent at a number of areas that are really years of work. If you can, if you do, yay. The mad science software is me going in and starting to get seriously competent at that work where I can. But I'm also doing it in an area, building a full host rather than a container, where there's a lot of good information because we've been doing it for so many years. Docker is like that, except not only are you not an expert at it yet, most of you, not only are you not an expert at it yet, but we're still learning the details and we're learning them fast. And that means that a lot of the information that you'll find just searching for it is out of date. Out of date in this case should be treated as a euphemism for can destroy your site because there are subtle but serious problems with it. Okay, Phil, I see you mentioned that Docker isn't ready yet in the mad science movement. What do you feel? When do you feel? What further steps does it need to actually be useful for production use? So I hit a little bit of that. The things I just mentioned address that somewhat. Docker, I want some DevOps too. Okay, I'll definitely answer that one as well. Second, I feel pretty competent to answer that at this point. Sorry, but not to skip ahead. Isn't ready yet. So Docker is still configured off a Docker file, and Docker file is still very much a shell script, and it's not a complicated shell script. It's hard to use conditional things. Docker solves the problem of I'd like to build what's essentially a binary VM image and then distribute it around and we can build on top of it, which is good. We haven't previously been able to do that reliably. Docker is a large step up because we can reliably do that. But it doesn't fix a bunch of other problems because it's not designed to. Like, what if we want to rebuild it from source? If you're going to rebuild your Docker file from source, you have the same problem that traditional solutions like Chef and Puppet, etc. do, because Ubuntu changes things on you and they upgrade packages and suddenly things stop working. There are extreme cases of how bad this gets, like stuff that packages the acceptable list of SSH key or SSL certificates directly into the software. That's certainly a thing that happens. But in general, when Ubuntu changes their set of packages, you should expect that there's a good chance it'll break your stuff. I see it happen all the time with mad science. And of course, you have to test separately on every platform because all the configurations are different. let alone things like different distributions. Docker solves this in an extremely simple way, where you have one straightforward, mostly linear file that just runs a set of known commands from nothing in a row and saves a partial disk image in each one. It's clever. I mean, I'm a Ruby guy. I absolutely appreciate simplicity. And at the same time, you can't easily share Docker files between multiple distributions. They're designed to work on one distribution. They're designed to hardcode everything. You can't easily share it when you change paths. They're designed to work with one set of paths. You hardcode the paths absolutely directly into the Docker file. You don't run the Docker files regularly as you can, but Docker doesn't make it especially easy. These are all things where the tool is wonderful. It does exactly what it says it does, and it's been well developed. And Docker is a remarkably solid tool for its age, technically. And the problem is we're still trying to figure out what workflows that use Docker should look like. We're completely new to that. We're still using Docker as though it were a fast, cheap way to ship VM binary images around, mostly. And it is that. It does a good job of that. But it's doing a good job. It's like a horseless carriage, right? We're still using it the way we would use a carriage with horses on it. We don't know what the right way to use a car is that doesn't look like using a carriage. Once we have some genuinely Docker-based workflows, which is going to require ways to automatically in software discover processes, wire things up. One of the things we're building for it is things like Zookeeper load balancers. So you can spin up new Docker containers, it'll immediately be discovered and start working. But the reason we have to build that is because that's not historically how we did these things. The tools for that are not terribly mature. Docker is a remarkably mature tool, and the whole infrastructure around it, the whole ecosystem of tools, is still starting to happen. It's not there yet. Great, so that would be my take on it. Charles says, Cuba and Rhoda are exceptionally easy to extend and have extensions for lots of options. I can absolutely believe that. I haven't used them, but those sound like great things to look into. Then Charles asks, let's see, there are lots of DevOps tools too. How do you pick between Chef, Puppet, Ansible, SaltStack, etc.? Another great question. So I know Chef and Puppet very well. Mad Science is built on Chef. Puppet was the tool that we used in my last company and this company. I used Chef in the company before that. I have a fair bit of experience between them. Chef and Puppet are extremely similar to each other. Chef and Puppet are the same generation of tools. Chef actually sort of grew out of the Puppet project by a fellow who wanted the Ruby-style syntax as a feature, and Puppet basically said, no, we're not going to do that. They eventually relented, but they relented in a way so it's not usable. So Chef was already meant to mirror Puppet. It grew out of the same community, it grew out of the same sensibilities, it grew from somebody who liked Puppet, and they feel the same, mostly. If you want to know the real difference between them, it's mostly the community. And if you want to measure that difference, look at the set of built-in resources that Chef ships with and the built-in resources that Puppet ships with. One of the things you'll discover is the Chef ones include stuff like Capistrano as a built-in lowest level primitive operation. And Puppet includes a bunch of things like Nagios, like a third or more of their resources, something crazy, start with Nagios. And what you're seeing is the cultural difference between one side of this was produced by ops people who wanted to configure Nagios, who wanted to install software, and who thought of it kind of like a shell script, and the dev side, which is Chef, where they want to have full Ruby in every config file. And they've slowly been growing together. Puppet has gotten more configurable. Chef has gotten more able to lock it down with things like lightweight resources and get that wrong there, LWRS, something like that, the lightweight resources system. So Chef and Puppet are really very similar in their sensibilities and in how they do things. Ansible follows that more or less. Ansible believes that mostly what you want to do is not write a lot of new resources and have a simple YAML syntax to put it together. And to be fair, they do a good job. The Chef syntax is Ruby, but it's not Ruby that's carefully optimized with a really good, really simple API. You can put together a better Ruby API, I think, for what Chef does. And Chef doesn't make it easy to install additional gems. They don't make it easy to tap into additional sources, which makes sense if you look at deploy code. There are a lot of reasons that for your deploy code, you don't necessarily want to easily pull in a huge amount of semi-tested third-party code the way we do with Ruby gems in most cases. But it means that there's a lot of room to do better. And Ansible does that using YAML files. It's very easy to get up to speed initially to get things started out in Ansible. They've got a wonderful first run experience, a wonderful first set up your app experience. They also don't push the central server as hard, which is nice. Chef pushes the central server, and so does Puppet, way too hard because that's where the company makes their money. And so the consulting companies that that write the documentation and do these things push that central server much harder than you would want as a hobbyist developer. They're aiming for enterprise. Ansible does not do that, and it's one of the very best things about it. It's not a difference in the technical capabilities. It's just a difference in how the documentation is written and how they talk to you and the way the announcements work. But Ansible is clearly aimed at the single individual hobbyist developer, at least somewhat. And Chef and Puppet are just not. They don't really care about that use case. Let's see. So SaltStack. SaltStack is the one I know the least about. There's a wonderful blog post about changing from Puppet to the guy considered both Ansible and SaltStack and wrote wonderfully about it. His take on that was that it's the community between those two. And you're Ruby guys, you care about community. So I think consider the community first is great advice for any of these tools. What he said was that Ansible is great about letting you get into it, but it's not as technically savvy underneath. Ansible gets very, very long run times to provision a server very quickly. It's just not designed to handle that well. The community does not do a good job of treating that as a real bug. In general, bugs that you report against Ansible, and all of these tools still have bugs, no question. This is all very new, very complex stuff. They're all going to have bugs. But bugs you report against Ansible don't get addressed very quickly. SaltStack has an amazing community, but they're also, I believe, the newest of these tools. I know much newer than Chef or Puppet. But they have a great community. They're great at addressing bugs. It's clearly got a lot of promise, and he finds that community is just a lot easier to work with than Ansible. They're better about acknowledging their bugs. They're better about fixing bugs rapidly. So he had great luck with SaltStack. The flip side of that is Ansible is really popular in the Ruby community right now, so you may want to just use it because there's a whole bunch of sample code you can use for everything. These tools have changed so fast and will continue changing so fast, their popularity and their actual technical underpinnings, that I wouldn't pick one purely based on what's currently hot in the community, because I don't think that'll last for any of the tools under any circumstances. This area is just moving too fast for that to be a good way to pick for these tools right now. As opposed to, we can always hire Java programmers. Well, that's true. You can always hire Java programmers from now till forever. But the DevOps tools are not in that category yet, and none of them will be. All right, great. Charles asks, when should you set up a load balancer versus optimizing your code or setting up a queue for long-running jobs? Sadly, for most people working in companies, the answer has everything to do with how responsive your ops team is. And the reason we wind up with level after level after level of load balancers, some of which you control as a programmer, is basically that it can be hard to get time from the ops team. Many Ruby tools are things that treat ops as damage and route around it. So like RVM, for instance, let's just install all of our Rubies and all of our gems under our home directory. Traditionally, that would be a terrible idea. You're getting an extra copy of everything. You're repeating everything. Why in the world would you do that? And the answer is, ops says we don't get write access to the rest of the machine. We'll put it in our home directory, continue on our merry way, and we're good. In the same way, some of these levels of load balancers are things where, well, we control this piece, let's put a load balancer in it because we need a load balancer, or we need more control of the load balancer, or etc. Load balancers, even the very front level ones, are extremely configurable. If you look at something like HAProxy or Varnish, they are very programmable tools. I mean, it doesn't look like Ruby. It's not a traditional programming language. It's optimized to be ridiculously fast. It has to be. But it's a good tool, and it's very programmable. They work really well. There's no reason a programmer can't handle a load balancer. I mean, it's very similar to the other tools you already use. When would you use a front-end load balancer? Trade-offs of Varnish versus HAProxy. There's a great page on this from the HAProxy folks. They're somewhat different tools, and they are commonly deployed together. HAProxy is a wonderful front-end load balancer. It's an extremely complicated load balancer that lets you switch back and forth on headers and whatnot. Sorry, I'm getting into another question. I'll answer both. Anyway, sorry. When should you set up a load balancer versus optimizing your code? If you need something to be extremely fast, pay attention to the outer layers, because the outer layers are adding additional overhead, and you can't get rid of that overhead. But the outer layers are also usually the hardest for you to modify. And so start with the layers you control the most quickest. So a queue for long-running jobs, for instance, you don't care about a few microseconds on that. It just doesn't matter to you. You're talking about something that can take seconds or minutes or sometimes hours. So great, yeah, start up a job queue for that. Optimizing your code, man, I gave a whole talk on profiling recently. But so optimizing your code can make sense. If you're doing it in Ruby, there's an excellent chance that the slow part is not in your code. Ruby excels at, let's do it in the database, let's make an HTTP request to do this, let's farm it out to an external server. If you're not doing that, then sure, optimize your code, absolutely. But if you are doing that, then optimizing your code doesn't usually help. And so the load balancer is kind of a last resort. It's a little harder to modify. You're going to have to go through somebody else, but it's also the place where the performance is the strongest. It's for old guys like me, I want to say it's a little bit like assembly language. Never go to it first, but there are some things that you can only do that way. And I think I go to hell for comparing a load balancer to assembly language, but it's a little like that. Okay, so sorry, trade-offs of Varnish versus. I did not hear that. Trade-offs for Varnish versus HAProxy. There's a great page on this from the HAProxy folks. They are different tools for different uses. HAProxy is a wonderful front-end load balancer. Varnish is a very powerful, very configurable caching reverse proxy. Okay. And so you would often use both. HAProxy is not very programmable for a lot of the cache down in the details, interesting stuff. Whereas Varnish is extremely programmable, but does not have the advanced load balancing algorithms. So when would you use a load balancer? For reliability, honestly, as much as anything. I mean, speed happens there, but for reliability as much as anything. When would you use Varnish? When you want to skip the later layers. As you go in toward the Ruby layers and the layers that the developer controls, most of those layers are just slower. And so you'll have a small percentage of your requests that need to return extremely fast. And for those, if you have to, go all the way up to the load balancer. If you don't have to go all the way up to the load balancer, but you do need it to be extremely fast, go to Varnish as the next layer. The next layer after that is NGinX serving static files, which is slower than that, but still very, very fast compared to Ruby. As soon as you hit Ruby, it's going to be a lot slower. Once you hit Ruby, you've got layers like Rails metal, which are served from the far outside edge of the rack middleware stack. So that's a lot faster than if it has to go into your app. So yeah, the trade-off is basically that you have a whole Russian doll series of trade-offs. You have a whole series of layers inside layers inside layers. And the farther inside you go to the slower layers, the easier it is to modify. And the farther outside you go to the faster layers, the harder it is to modify. Figure out how much you care about the performance for this specific case, and go as far outside as you have to, and no farther. Oh, cool. All right.
Any other questions?
All right. I was surprised not to hear more questions about rack middleware, but to be fair, that wasn't what I announced the talk was about. So maybe that got asked elsewhere. But in general, for all of this stuff, if you wanted a practical way to speed up to make your code more configurable, including speeding it up in any way you can do it, I highly recommend going and finding out more about rack middleware. I've got some good talks on that if you go look, including a talk with the Ruby Hangout. There are also a number of good blog posts, of course, lots of blog posts. Unfortunately, the documentation for rack itself is not very good, but if you can find some example middleware, and there's lots of great example third-party middleware. Let's see, recently I've been looking at profilers. So Justin Weiss's request profiler that runs RubyProf, the Ruby profiler, on every request is a great example of interesting configurable middleware that's still kept reasonably simple. You can make it extremely simple, but if you want a good example of what it actually looks like to do a non-trivial thing, that's a good piece of code that gives you an example of how powerful rec middleware can be. And it's the same kind of thing. Yeah. Yes, I can absolutely put a link to that on the chat. Let me do that. Thank you. That is a fine request. There we are, Justin Weiss's request profiler. The other thing I should absolutely put a link to in the chat is, given that I used Google Docs for the slides, here are the slides to this presentation, if you want to go back and look at anything, which is also where the discount coupon is for my book, if you want to pick up a copy of my book later. Great. I think I've addressed all the questions.
All right. Well, thank you then, Noah. I appreciate you taking the time out. Share with us.
I appreciate you asking me to. Thank you very much. I've had a lot of fun. I hope you have too. I see somebody typing.
Definitely. All right. Well, we have about 5 minutes before the next talk. I'm going to give another quick shout out to Hired.com. Thank them again for sponsoring. I honestly don't know if I could have done it without them, so I really do appreciate it. Go check them out, hired.com/RubyRemoteConf. I think you've heard the spiel before, with the auction from companies in San Francisco, New York, and LA. They're looking for people like you, so if you're looking for a job or you know someone who is, they do more than just Ruby too. So if you know somebody who's looking for an iOS or JavaScript job or something, they do all that stuff. So go check them out. They get a $4,000 signing bonus if you use our link. It's $2,000 otherwise. So if Hired.com finds you a job, then yeah, they'll hook you up. So
nice.
So go check them out. And we've got about 5 minutes before the next talk. So, and that's going to be Peter Cooper. So yeah, hang tight. We'll get him set up, and then we'll get going.